And we have a formula. So the formula is lowercase s is measured in squared meters. And the formula is the square root of HW over 3,600. Let's see what H represents. W is the patient's weight in kilograms. So weight in kilograms is W. Lowercase h is the patient's height in centimeters. So lowercase h, its height in centimeters. Okay. And the source is the US Oncology Institute. Use this information for exercises 73 and 74. Assume that the patient's weight is 70 kilograms. And then assume that the approximate this patient's surface area, assuming that in part A, the patient's height is 150 centimeters and the patient's height is 180 centimeters. I know you probably cannot see here. I'm just moving my stuff away. So we're asked to calculate the body surface area. And we have the square root. H is 150. So for part A, 150 centimeters. The weight is given to us as 70 kilograms and divided by 3,600. And I'm going to write B as well. And then we use the calculator for both. So now the height is 180. Weight is 70 and 3,600 is the number in the formula. So careful with all this. I'm going to share my screen so we can enter this together. So here is the square root, second, and where you see x squared. Again, some calculators may do without parentheses, but others will not. So I will put the parentheses we need. Left parenthesis, 180. Because the top is a product, it's okay to write it like this without parentheses, additional parentheses, and divide by 3,600. Close the parenthesis. So, oh, I'm sorry, I jumped to the second one by mistake. Sorry about that. So 180 times 70 divided by 3,600. And what I like to do, and I want to show you this, especially with large formulas, go to second and entry. It copies what you had before. And what I need to replace is just the 8 and overwrite it by a 5. Not because I'm lazy to rewrite it, but sometimes, especially with the quadratic formula, I highly recommend do this. Okay? So I went to second and entry. It copied what I entered before, not the final answer, not this answer. And then when I press enter, it calculates. So the body surface area for the second person in squared meters is 1.87. And for the first one is 1.71. Let's see if they give us any indication. They don't round your answers to the nearest hundredth. Yes. So we're going to do that. So the first one is approximately 1.71 squared meters, and the other one approximately 1.87 squared meters. And I'm going to stop sharing. So careful how you enter the calculation, the numbers in the graphing calculator. Okay, I don't have anything else to say about R.2. And you will tell me if you find anything that we need to look at. So in R.3, so R.3 deals with domain and range, which we know a lot about. So I'm going to directly go to domain and range. We already looked at a lot, but we'll look at more. Okay, so let's start with I really needed those graphs. And let me know if it's working so I can go back in, because I like to show some graphs. Okay, so I would like us to look at problem 36, which is f of x, the square root of x minus 2. I'm going to copy a few. 44, f of x, 2x minus 1 divided by 9 minus 2x. And why not? Let's also copy 54. So g of x is 3x minus 10 over x squared minus 4x minus 5. Okay. In all these questions, we're asked to find domain. Okay. So problem 36, how do I start? Zainab, are you here? She's my friend from a totally different class. I tortured her and she came back for more. Thank you. Just kidding. So how do I start? You remember this? What do I have to write in order to find the domain of this function? What can we take the square root from?
No negative numbers?
No, never from negative, just from positive or 0. So the square root can be taken from positive or 0. So then I have to write what restriction?
X can't equal positive 2 or anything greater than?
I have to write x minus 2 has to be greater than or equal to 0, right? So this quantity has to be 0 or positive. I don't have to guess anything. This is the first step, the first thing I have to write. Whatever I have here has to be either positive or 0. Everyone in agreement with this? Now I solve. I don't need to solve. I need to show first what it means and what I'm trying to do. And now I solve. So how do I solve this?
Add 2 to both sides.
Right, x greater equal to 2. So then what is the domain for problem 36?
Bracket to infinity.
Perfect. That's the domain and it's done. You may encounter the domain written in the set builder notation. This is interval notation. This is what I prefer, but MyLab Math may ask you to use the set builder notation. Why I think it's not useful, but it's okay, is because it really copies this. So it uses braces. It says the domain has values of x. This vertical bar stands for such as, or having the property that x is greater than or equal to 2. I don't really care for this notation, but you may be asked to use it. I will not ask you to use it because it's the same thing. What is this? What's the real difference here? So I prefer the interval notation. This is the set builder notation. It means the domain consists of values of x, such as, or having the property. What property? That x, all these numbers have to be greater than or equal to 2. Okay, let's look at 44. Okay, so 44. Savannah, would you like to try? So 44 has this function. What could go wrong here?
Well, my first thought would be to set them equal to 0.
Which one?
Well, wouldn't you do the numerator and the denominator separately, or?
So there is no restriction. Never any restriction is needed for the numerator. If the numerator is anywhere between negative infinity, infinity is never going to be restricted by any means in this kind of problem. However, the potential situation will be what?
The denominator?
Right. So the denominator could be the problem. Why? Can anyone explain? Rita, you want to tell us?
Yeah, the denominator can't equal 0 because you never divide an equation by 0.
Yes, we wrote that. Thank you so much. We wrote that some time ago. Division by 0 is a problem, is undefined. This is a fancy word that really means it does not exist. But instead of using 4 words, we like to use just one. Undefined. But that's what it means. It does not exist. So then how do I solve this? 9 minus 2x. I move 9 to the other side. What happens when I move one term from one side to the other?
It flips sign.
Very good. And then what do I have to do? X not equal, of course. Not equal to what? Haber, are you with us? So he's the one who's not here. Now I know. Lake?
X can equal 9/2.
Very good. So now how do we write the domain? Great job.
Wouldn't it be negative infinity, comma 9/2? Yeah, in parentheses, and then 9/2,
Very good.
comma infinity.
Awesome. Excellent. So this really means everything but this. Great job. Thank you. And one more.
Sorry, I think it's a silly question, but what is the thing in the middle?
Union.
Okay.
It's a mathematical symbol that says basically or. So the domain represents all x values that the function can take, either here or here. That's what this means, or union.
Why do you add a union to this one?
Why do we what?
Why do you add a union to this specific one?
Because there is no other way of writing it.
But in other ones where there's been like a gap of values that weren't included, I don't remember seeing it. So is there a specific type of gap?
Yeah, we did use it before. Every time there is a gap, we use the union. It's a very good question. We can go back.
Because I thought the piece, I didn't remember it from the piecewise that we did.
Let me share my screen. It's a very good question. I'm sharing my screen. I'm going to modules. Okay. When did we write domain for this? It was not the first. Was it the first day or the second day?
I think it's, if you go up, it's just.
I don't remember if our first meeting or our second meeting. I don't think we did it in the first meeting. I was too lazy. I was talking too much. Yeah, so let me check the second meeting. So this was lecture notes. Here is lecture.
Yeah, I was on 127.
I'm almost certain I used the union symbol, but when you get to my age, you want to check. You want to check your memory. Aw, what is going on here? Oh, I have to check from now on. Sorry about that. Look at that. Oh no. And I got rid of that. Oh no.
It was actually that problem too.
I know it was this one, but look what happened to my file. I'm so sorry. Can anyone show the union symbol there? If you have it, I'm sure I used it. I had to determine the range of this function. I used the union symbol for sure. Yes. Yeah. Oh, my apologies. So I can write a range here for you one more time for this function. So the range for that function on page 6 out of from the lecture notes on 27 of January will be negative infinity to 1, union 2, and union 3 to infinity. Okay, so here it is. One more time, my apologies. Negative infinity to 1, union 2, because this is just a finite number. In this case, just one number. Union again, 3 to infinity.
The squiggly
This,
bracket, if it's just a finite number,
yes, this is a parenthesis. Yep.
but not a normal parenthesis, like a.
You cannot use parentheses for one entry. It has to be an interval. So the
Yeah.
parentheses and the bracket used for intervals. This is a number is not an interval.
What are the two things on each side of the two?
Braces.
Braces. Thank you.
So these are braces, this is parentheses, and this is bracket.
And so braces are for finite ones.
Yes.
Only.
Yes.
Okay.
So if I have a set with 2 and 3 and 10, I cannot use an interval because an interval includes everything between 2 and 3, but I don't have 2.5. 2.5 is not here. I don't have 7. I cannot use 2 comma 10 because 2 comma 10 includes even 9.9 and 8.3 and 7.2. But this is only, it only has 3 elements. 3 elements. Oops. Okay. I know I have to wrap it up. I have 2 more minutes. At least let's just start the last one that I copied for you. This one. So this is my page 7. And this is g of x equals 3x minus 10 divided by x squared minus 4x minus 5. So this is very similar to the previous one. But what we need to do here, Alex, would you like to tell us?
Factor.
Of course, thank you very much. Good, excellent. Alex is another best of my students from a different class, totally different class. Well done. Can anyone give us the factor form?
X minus 5, x plus 1.
Perfect. So what will then be the conditions or restrictions?
X can't equal 5 or negative 1.
Very good. Finally, the domain in interval notation, and then we'll stop.
Be negative infinity to negative 1.
Very good. Awesome.
And then negative 1 to 5.
Awesome.
And then 5 to infinity.
Great job.